All right, guys, let us continue from where we stopped. In our former video, we did the introduction to Laplace transformation. Then we found the Laplace transformation of 1 and Laplace transformation of t. So in this video, we are going to be finding the Laplace transformation of t raised to power n. Okay. Or let us prove that the Laplace transformation of t raised to power n is equal to n factorial all over s raised to power n plus 1. Okay. Now, to prove this is very simple. We are going to say we know that the Laplace transformation of any function of t is equal to the integral from 0 to infinity of e raised to power minus st, then t raised to power f of t, f of that function. Okay, then dt. Now, having known this, you should now know that the Laplace transformation of t raised to power n should be equal to the integral from 0 to infinity of e raised to power minus st, then t raised to power n dt. Okay. Now let's say that let this be equal to x. So let us say let x be equal to what? St. Okay. So from here we are going to have that the s is equal to what? S dt. Okay. To show that from here, if I make t subject, t, this one implies that t is equal to x over s. Why this one implies that the t is equal to the x over s. Okay. So let us substitute all these things we did now. So this is now the Laplace transformation of t raised to power n is equal to the integral from 0 to infinity of, now if I substitute it here, I'm going to have e raised to power minus x. Okay, this is x minus x, then t is the same as saying x over s all raised to power n, then the t is something as saying the x over s. All right, now having this, so this should be equal to, if I bring out all the constants, this and this will give us okay, this is something as saying the integral from 0 to infinity of e raised to power minus x, then this is x raised to power n over s raised to power n. If I share the n for both of them, okay, it's being multiplied by 1 over s, then the s to stay on its own. Okay, now according to the law of indices, this is raised to power 1, so they can just add, because this is going to be the integral from 0 to infinity of e raised to power minus x, then I'm going to have x raised to power n over s raised to power n plus 1. Okay, according to indices, add the power if the base are the same thing, the s. Now I hope you know that this is a constant, so bringing it out, I'm going to have 1 over s raised to power n plus 1, the integral from 0 to infinity of e raised to power minus x, then s raised to power n, the x. Now if you solve this integration by parts, it's going to give you n factorial. It's going to give you this one here factorial. Okay, it's already proven. You can try it yourself. So this is now 1 over s raised to power n plus 1, then multiply by n factorial, which will now give you n factorial all over s raised to power n plus 1. So this is it. So the Laplace transformation of t raised to power n is the same thing as saying n factorial all over s raised to power n plus 1. Okay, so this is the first way of proving it. Now the second way of proving it is that we know and we proved in our former video that the Laplace transformation of 1 is the same thing as saying 1 over s, right? 1 over s. We got that in the former video. So if you know this, and then we know again that the Laplace transformation of t is the same thing as what? 1 over s squared. Okay? The Laplace transformation of t squared, you can try it, is going to give you 2 over s raised to power 3. The Laplace transformation of t raised to power 3 will give you 6 over s raised to power 3. Sorry, s raised to power 4. And if you look at this is something as saying 2 times 1 over x cubed. Okay? Or 1 times 2. Let me use 2 times 1 is okay. So this one is something as 1 times 1. Okay? Over s squared. And 1 times 1 can be written as 1 factorial. This one can be written as 1 times 0 factorial all over s. So this one can be written as 2 factorial all over x cubed. So this one could be written as what? 3 times 2 times 1 all over s raised power 4. Okay, which is something as what? 3 factorial all over. Now 4 could be written as 3 plus 1. This one could be written as 2 plus 1. So you see the way it's going. So this is now showing us that the Laplace transformation of t raised power n is the same as saying n factorial all over s raised power n plus 1. So that is that for that. Equal by on a day confused.